Hello once again, friends, and welcome to episode 116 of Just the Zoo of Us. This week, a spectacular evolutionary biologist is here to talk about the dimensionally innovative flatfish. Get ready to learn the story of why these quirky fishes developed such peculiar body plans and how their bizarre adaptations help them live their best life beneath the sand. We are going to talk migrating eyes, transient feet, and which cartoons got flounders right and which ones got them wrong. So stick around to the end for announcements, plugs, and a sneak peek at next week's episode. Without further ado, Just the Zoo of Us presents Flatfish with Dr. Kory Evans. It's Ellen Weatherford. I'm here with Just the Zoo of Us. This is your favorite animal review podcast. I'm so excited to introduce to y'all a new friend for today. This is Dr. Kory Evans. Say hello, friend.
Hello, Ellen. How you doing? And hello, everybody else.
I'm great, and I'm so excited to talk to you. We're talking about a very underhyped fish today, I think. You've brought a very fascinating and maybe not like the world's most, what people think of when they think of a charismatic fish, maybe not. But hopefully we can hype them up a little bit today. But before we talk about our flatfish today, tell us a little bit about the kind of work that you do over at Rice University.
Okay, cool. Yeah, so I'm an assistant professor at Rice University. I just started there now 2 years ago. So I study the evolution of fishes and the evolution of morphology. So what that means is that I'm really interested in how traits have changed over time, over the course of millions of years, and how we get like current patterns of basically morphological diversity that we see today. So that involves a lot of going to the field, catching fish, figuring out what they're eating, because sometimes different aspects of ecology can have some really kind of marked influences on why animals look the way they do. And then we spend a lot of time kind of collecting morphological data. In my case, using a micro CT scanner, which many people might have experience with. If you go to the doctor's office, you might have an MRI or a CT scan where you can create these really nice three-dimensional images of skeletal structures or basically just the inside of an object. So we use that to collect three-dimensional data for skull shape for these fishes. So that's a lot of what I do, is basically scanning fish and measuring them when I'm not in the field.
I have seen, so I follow you on Twitter.
Oh, nice.
And some of the stuff that you have posted on there, like images of 3D models that you've constructed of these fish skulls, they're mind-boggling. They're beautiful and they're so cool.
They are really cool. And the crazy thing is, like, frankly, the fish do most of the work, right? I think that's why they're so beautiful, is like the fish, like all I do is just, show the image and I just find what's already there or image what's already there. So the skeletal morphology of fishes is really striking.
Yeah, there's some very shocking adaptations you see in a lot of fish. One that comes to mind, since we're talking about the work that you've done on fish skulls, a fish that I learned about from following you, is the sling jaw wrasse.
Oh, yeah.
While we're on the topic of fish skulls, I think we can take a quick second to mention the sling jaw wrasse.
Yeah, we have to. Yeah, so the sling jaw wrasse, so wrasses in general they belong to this large family of really, really charismatic coral reef fishes. I think wrasses are present on just about every shallow water reef on the planet. And the sling jaw wrasse in particular has the ability to extend its mouth. What is it, like 1/3 of its total body length or something like that? Or yeah, it's absurd. So basically they can just like shoot half of their face towards the target. And like you're hearing my voice like kind of explain this. And just seeing it is, that much more kind of really striking. And it's funny because they look like a regular fish. Like you'll swim up on them. If they're not feeding, they look like any old fish. And then if they strike at something, they look like an alien for 2 seconds. And it happens really, really fast. So they look like an alien for 2 seconds until that jaw retracts back into their head. It's insane.
It is. It's so wild to see.
Yeah.
Like I've seen you post little videos of them like shooting their little. It's like they've like detached their whole mouth and are just like throwing it at whatever they're trying to catch. It's so
Yeah.
wild. It's like if you've ever played like an RPG where you can like put skills into different perks, it's like they've somehow like maxed out their melee attack and like turned their melee attack into a ranged attack where they can just like go gadget mouth.
That's true. That's true. They definitely, I don't know what stats they maxed out on to get that. But they did something.
Yeah, it is really cool. We're not talking about slingshot wrasses today. I just wanted to give an honorable mention because it's a very cool fish that I cannot think about like fish bones without thinking of the incredible slingshot wrasse. So before we talk about flatfish, what got you into fishes? Like, what was the kind of impetus, I guess, for working with fish specifically?
That's actually a great question. So when I was a kid, I was always kind of into animals in general. I grew up watching Crocodile Hunter, grew up watching Jeff Corwin. I was a huge Jeff Corwin fan. As a kid, we had the little like cable box, and I was too small to see the little buttons on the top of the cable box. I just memorized where Animal Planet was and where Discovery Channel was just by touch.
Dedication.
Yeah, it was wild like that. And my parents used to take us out all the time, especially during the summer. I grew up in North Philadelphia, so we used to like drive out to the Jersey Shore every weekend to go to the beach. And while I was there, we would like link up with the like state rangers and stuff, and we would go seining. And it was like the coolest thing ever. And I don't think they really do that anymore. But we would seine, and then there were like scientists on staff who would talk to us about what comes up in the seine. So if anybody doesn't know what a seine is,
I don't.
Yeah, it's this really, really long net that it takes like a team to pull. So you stretch it out, you walk into like a shallow kind of coastal habitat, and then you basically just pull the net back towards shore, and you catch a lot of stuff that way. The cool thing about seines is that like you never know what's like 5 feet away from you. If you're sitting on the beach and it might look like nothing's there, and then you'll run a seine and it'll be full of fish. You're like, how did this happen?
Wow. Did you ever pull it back in and see something that you just wish you had not known was there?
At that time, as like a little kid, I wanted to know everything that was there. But the annoying thing about seines is that you caught a lot of like blue crab, and blue crabs are just really bitey. So you just used to get wrecked by the blue crabs.
That's the price you got to pay for knowledge.
It's true. But so during these seining events, we would catch horseshoe crabs, and this is where the story gets interesting. So we would catch horseshoe crabs, and that was like our family, like my whole family was nuts about horseshoe crabs, right?
Rightfully so.
Because we knew they were cool. And the reason why we knew they were cool is because there was a marine biologist on staff who was helping us out. And I didn't know what a marine biologist was at the time. This was just a person to me who knew a lot about horseshoe crabs. So one day we're not sailing, we're just hanging out on the beach with the regular people, and a horseshoe crab washes up on shore, still alive. And there are kids like poking it with sticks and like flipping it over and messing with it. And I run over and I shoo them away. And in all my sailing experience, I had actually never been taught how to handle a horseshoe crab. So I was just kind of just like hunched over it, trying to protect it. And this woman comes up. She's like, oh, you're doing a great job. I'll take it from here. And I was like, who are you? Like, I don't trust you with this horseshoe crab. And she's like,
this
right?
is my baby.
Yeah, like this is my guy, man. I don't know how to get it out of here, but I also don't, like, do you know? And she's like, oh, I'm a marine biologist. And I was like, what on earth is that? And she explained it, and then she walked the horseshoe crab back into the ocean, and I ran back to my folks. I was like, I'm going to be a marine biologist. And yeah, it was cute. And I was like 8.
That is the most heartwarming, like, what I want to be when I grow up story I've ever heard.
Yeah. And it
worked.
It did work. And by the age of 14 or 15, I had like 7 fish tanks in my bedroom.
Okay. So this is a deep-seated appreciation for fish. This goes way back.
Me and fish go way, way back.
Oh my gosh. And like horseshoe crabs are also such fascinating little critters that come out of the water. So wow, what a delightful experience. I hope that the marine biologist that helped you with the horseshoe crab like has their perspective of that event in their memory also. I hope that just was like a core memory for both of you.
I hope so. Fun fact though, I went back to that beach. It's Island Beach State Park. I went back to that beach. And they still have the fish tank that we used to catch some fish and put them in like a display tank. They still had the tank there. So that was really nice.
Wow. What a throwback. So let's talk flatfishes.
Oh yeah, let's do it.
I'm so excited to talk flatfishes because you mentioned the flounder as an example of a flatfish, but are there other flatfishes? Tell me, what is a flatfish? I'm sorry.
So a flatfish, if you haven't seen them or heard of them, flatfish basically refers to a group of about 800 species of fishes that have asymmetrical faces. So what this means is that both eyes on the head of this fish are on the same side, usually the left or the right, and they have a completely blind side of their body that they basically lay on. These fishes are basically bottom dwelling. They lay on top of the substrate, or they can kind of bury themselves underneath of it, and they'll have like both eyes like sticking out of the sand. Really, really weird fish, like arguably some of the weirdest vertebrates on the planet.
It is strange because you don't see a lot of vertebrate animals that don't have that sort of like symmetry, right?
Yeah.
That's unusual, right?
Yeah, so like some vertebrates have a little bit of asymmetry, like owls have asymmetrical ears, but nothing on the vertebrate on the planet comes close to what flatfishes are doing.
It's very extreme. So you mentioned that you studied like evolution of the fish over millions of years.
Yep.
How did that work for the flounder? Like, did the eye just kind of slowly make its way to the other side? Because that's hilarious.
Man, that's actually a great question. So basically, so let me set the stage, okay?
Okay, paint me a word picture.
Yeah, 66 million years ago, right? Like a dinosaur, a dinosaur lifts his head up, looks at the sky, a meteor slams into Earth, murks him. Right.
KO.
Yeah, they got
team wipeout.
They got smoked. They were straight up not having a good time. But it was different for fishes. So a lot of fishes went extinct. But over time, basically, what ended up happening is sea levels rose. And what happens when sea level rises is that you get more shallow habitat, which is something that we, in Houston are kind of worried about now as sea levels are rising, because now that shallow habitat is like our cities. But back then, there were no cities to flood. It was just more kind of coastal habitat. And what ended up happening was over the course of about 2 to 3 million years, this kind of group of pelagic fishes that swim in the water column essentially started migrating one of their eyes gradually, mind you, to the other side of their body and settled on the benthos. And now we have flatfishes. So I published a paper earlier this year, kind of charting out the evolutionary history of the transition to asymmetry in flatfishes. And the crazy thing is, it happened very, very, very fast. So 2 million years, 2, 3 million years is a blink of an eye. As another paper had mentioned a couple years ago, that is very fast in evolutionary time. And yet it was still gradual. So this is a gradual yet rapid transition to asymmetry.
So like once it started, they were like, all right, we need to fully commit. Go, go, go. Get that eye over there.
What they absolutely committed. Yeah. So we have like analyses where I can like paint the branches of a phylogenetic tree, which is basically just a diagram of all the relationships of fishes. I can paint the branches by the rate of evolution, right? And when you get to the flatfish branch, it is bright red. They took off.
I would imagine it would probably kind of goofy if they had like one eye in its normal spot and the other one at like not quite all the way over yet, but like at a very bizarre angle.
Oh, no, they did that.
They're like, this is not working. We got to get it over there.
Yeah, so they totally did that. We have transitionary flatfish fossils. And there's actually two or three species of flatfish today that retain that ancestral condition, which is super, super cool.
Does it look so goofy? I'm imagining that it must look so goofy.
It looks absolutely absurd. They all look absurd, to be clear. But this, they're called turbits, and turbits look ridiculous. Yeah, they look like, if you look at them at the wrong angle, like if you look at them from the top, because basically that their migrating eye stops migrating at the midline. So if you look at them like from the top of their body, like they look like a cyclops.
Oh my gosh, that is so funny.
Yep.
So they have one eye that stays in place and a migrating eye?
Yep.
Is that how it works?
Yeah, that's exactly how it works. And depending on the species or the family of flatfish, either the left eye will migrate or the right eye.
Okay.
Yeah.
Does it make a big difference whether it's like the right or the left eye, or is it just kind of like whichever one gets moving first?
Well, so the funny thing is some flatfishes do both within a population. It's kind of wild. Yeah, especially those early branching flatfish that kind of still have the transitional migration, they do both. It's like 50-50 in their population.
Wow. Is it kind of like being left or right-handed? You're like left or right, like
face? Yeah, isn't that crazy? Like, can you imagine and so to be clear, when the eye migrates to the other side of the body, all the other sensory structures get flipped too. So it's not just asymmetry in the eye, it's asymmetry all across the face and all across the body. If you flip a flatfish over, one side has pigment, the other does not. One side has scales, the other does not. So everything is flipped. The brain is all twisted and weird. And the idea that they can do this, like flip, like left eye or right eye migrated within a population, is absolutely like wild. It's heinous. Like because they're inverting their entire body. Like, can you imagine if a squirrel
Right.
was just running around inverting itself? It'd be
At a
horrible.
90-degree angle.
Yeah, that'd be horrible. And like fish just do this, like no sweat,
Like it's
like
nothing.
nothing, and then make 800 species of themselves.
They're like, yeah, this is actually great. Let's make 800 of these.
Yep.
Send it to print.
Yeah, we like this.
You said this is like a response to these like more shallow water environments. So the water's a little more shallow. They're doing this very bizarre flattening with their body. I want to think about how this very unusual, but apparently not that unusual because 800 of them do it. Yeah. How that is like a response to their environment and how it might be helping them. What do you give the flatfishes out of 10 for effectiveness, which for us is physical adaptations to the body that lets the fish do a good job of the things it's trying to do?
I mean, I give like, and not to, overrate them, but I give flatfish like a hard 9.8.
That's very good.
And there's a reason for this. So they basically, in kind of becoming asymmetrical, they've become beautifully flat. And they've kind of repurposed fins that were used for different types of locomotion for basically burying now. So a flatfish can basically lay on the bottom and throw sand over its body and completely submerge itself with only its eyes sticking out. And because they're so flat, they can actually move into really, really shallow habitats where other predators can't get to them, but where they can also kind of hunt where many other fishes cannot.
Oh.
So it's really impressive.
What are they hunting?
Well, across 800 species, there's a ton of variation.
True.
So the halibut is one of the larger flatfishes, maybe the largest. It gets like 500 pounds.
What?
Yeah.
Really?
We've been eating halibut our whole life. And like, before this paper, I never asked, like, what is a halibut? Like, what does it look like?
I'm not a seafood eater. So like, I'm tragically unfamiliar with like even very, very common like culinary
Yeah.
fish.
Listen, halibut, they live up in like Alaska and the Pacific Northwest. They are gigantic, monstrous flatfish that eat fish. They have gigantic teeth. You can catch them in the water column. They'll swim up in the water column and hit your bait. There's thought that the indigenous people who kind of fish in these areas early on actually had exclusionary devices on their fishing hooks to keep from catching large halibut because large halibut can kill you. It's like not a trivial matter. So
not trying to invite that energy into their studio at this moment.
Exactly. Yeah. So basically, halibut eat fish. Many other flatfishes also eat fish, and then some eat crustaceans and other kind of aquatic arthropods. So there's quite a bit of diversity in what flatfishes eat.
Okay. Are they hiding under the sand so that they can just kind of like ambush their prey? Or like, what does hunting look like for a flatfish?
So a lot of it is ambush predation. So these flatfishes, they have really phenomenal suction feeding abilities.
Suction feeding.
So they'll close their mouth really tight and create negative pressure. And underwater, it's kind of like drinking through a straw. And then they rapidly expand their mouth and bring in like a gigantic kind of rush of water and let it flow out of the gills, but they catch and capture whatever was sitting in the water. It's a very common way of feeding in aquatic ecosystems. And it's necessary because I don't know if you've ever tried to grab something like floating in the water, but if you move your hand too close to it, it actually moves away from you.
Sure, because you're like pushing the water forward as well.
Exactly. So what many vertebrates, but especially fishes, have done is they bring the water to them using suction feeding.
Absolute galaxy brain move.
Yeah, it's amazing. So flatfishes are ambush predators. They'll sit in the sand and then boom, explode out and catch their prey.
Do you remember watching the old Zoo Books commercial?
Oh, of course.
There's like an iconic moment in the Zoo Books commercial where a fish explodes out from under the sand.
I want to tell you that while I was describing this just now, I was thinking about that Zoo Books clip.
I'm imagining the image of the fish jumping out from under the sand, and in my head it's the announcer's voice going, "And the dark depths of the ocean." You know what I'm talking about? Like,
yeah. So that was an angel shark, but it's same business in terms of suction feeding and ambush strategy.
Wow, I feel like there's a lot of fish that do this, like burrow under the sand and chill and wait, because we've done an episode on stargazers.
Yep.
Which do something very similar where they have their eyes on the top and they go under the sand, chill and wait for something to swim by. But they have not fully committed to that whole like rotating their body 90 degrees. That's a very unique strategy.
So if you have a sec, let's talk about that.
Okay, yeah.
The thing that always gets me about flatfishes is that they did not have to do it this way. Like, I want to be clear, and I'm glad you know about the Stargazer because that's evidence that they did not have to do it this way.
They're playing on expert mode on purpose.
They really did. There are stingrays that just go flat like a regular fish, right? Like they just turn into a pancake and they have their eyes, they're still symmetrical and their eyes are just on the top and it's fine. There are other fishes. So flatfishes belong to this larger clade of fish. They're mostly pelagic, so they include things like swordfishes, mahi-mahi, remoras, like cool things like that. And the funny thing is that remoras have beautifully flat skulls. So basically, the blueprint for having a flat skull was already there. They didn't have to do this.
This was unnecessary.
Largely unnecessary.
That's really funny to me because it is an interesting example of how, like, evolution will get you the answer, but not necessarily in the best way.
Exactly. And this is what I teach at Rice, and this is what I try to impart on my students is that, listen, guys, like, evolution is not going to give you the best answer. It's going to keep you alive.
It's going to work, but it's not necessarily going to be pretty.
Exactly.
It's like when you're doing, like in school, when you do a really, really complicated math problem and you somehow showed your work where you got all the steps wrong, but you still arrived at the right answer anyway.
Yep. And evolution's not going to dock you points.
You get to stay alive, baby. There you go.
Yeah. They're like, did you reproduce? Fine.
You got results. You mentioned that like one side of them will have pigmentation and the other doesn't. Is this that thing where a lot of fish have where like they're darker on the top and lighter on the bottom?
Yeah, but like way, way more extreme. So because they're just like completely devoid of pigment. So like one side will be white and the other side will be completely beautifully pigmented and brown or bluish and things like that with all kinds of spots and stripes. And the other side would just be completely blank because they're laying on that side.
Okay. Would you find flounders or flatfish in general, would you find them more in like flat areas? Like I'm thinking maybe like off the coast of a beach. Would you find them like in a reef environment or like somewhere where it's kind of rocky?
So you can find them in a bunch of different places. So you can find them like right off the kind of the shore in the beach and kind of the really sandy area. I found them on reefs. Most of them like to bury. So like substrate. So if it's too cobbly or too rocky, you might not find many flatfish. You might only find like the really large ones, like halibut will hang out there because large halibut no longer bury. When you get that big,
I mean, like, why bother at that point?
Why bother, right? You can just swim around and destroy things.
It's like the elephant strategy of like, I'll just be too big that nothing will bother me.
Yeah. So yeah, you can find them in a ton of different places. There are lots of flatfish, predictably in the deep sea, because that's the bottom of the bottom, and they're there. So yeah, they're everywhere.
Are there other animals that are trying to eat flounder? Do they have to worry about like escaping from predators?
Oh yeah, I mean flounder tastes delicious, right? So and everyone's figured that out. So lots of things eat flatfishes for sure.
How do they get to them?
So sharks are really, really good at basically sharks are electroreceptive. So burying in the sand means nothing because right every time your heart beats, it gives off an electrical pulse. Many other fishes are also electroreceptive, so not just sharks. And they can also locate flatfish even if they're buried. Flatfish have to come out sometimes. They have to come out sometimes and they get hit that way. Lizardfishes will eat them.
Lizardfish?
Oh, yeah.
I've never heard of a lizardfish. What is a lizardfish?
That's a whole other thing. My friend Ben Frabel made a whole Tumblr about them. They look like Muppets, except they're like Muppets with teeth. Like they will eat anything they can. And the Tumblr is lizardfishes eating fishes, where they more than often like bite off more than they can chew. They'll try to eat a fish that's like bigger than their head.
Oh my gosh.
But yeah, they're like these voracious little predators that live on the bottom in like coral reef habitats.
Oh man, you got to look out, flounders. I guess burrowing in the sand is really only going to protect you against like more visual predators, right?
Yeah.
Hi there. We're going to take a super quick break to hear from a couple of our buddies on the Maximum Fun Network. When we return, we are going to talk ingenuity and aesthetics, so stay tuned to dig deeper into the flatfish life.
Hey kid, your dad tell you about the time he broke Stephen Dorff's nose at the Kids' Choice Awards?
In Dead Pilot Society, scripts that were developed by studios and networks but were never produced are given the table reads they deserve.
When I was a kid, I had to spend my Christmas break filming a PSA about angel dust. So yeah, being a kid sucks sometimes.
Presented by Andrew Reich and Ben Blacker. Dead Pilot Society, twice a month on MaximumFun.org.
You know, the show you like, that hobo with the scarf who lives in a magic dumpster.
Doctor Who?
Yeah.
Hi, I'm Annabelle Gurrich.
And I'm Laura House.
And we're the hosts of Tiny Victories.
My tiny victory is that I sewed that button back on the day after it broke.
We talk about that little thing that you did that's a big deal to you, but nobody else cares.
Did you get that Guggenheim Genius Award?
We don't want to hear from you. We want little bitty tiny victories.
My tiny victory is a tattoo that I added on to this past weekend.
Let's talk about it.
My victory is that I'm 1 year cancer free. But my tiny victory is that I took all of the cushions off the couch, pounded them out, put them back, and it looks so great.
So if you're like us and you want to celebrate the tiny achievements of ordinary people, listen to Tiny Victories.
It's on every Monday on Maximum Fun.
Our next category that we rate animals on is ingenuity, which is behavioral adaptations that the animal has that let it either, prey on other things, not get preyed on, survive, reproduce, get to the next level. What do you give flatfishes for ingenuity?
For ingenuity, so if we're restricting ingenuity to like behavior, man, I gotta give them like a 9.
Yeah.
Maybe like a 9.1 or an 8.9. So in that neighborhood. So flatfish locomotion is another really kind of cool thing.
Oh yeah, how do they move if they're twisted sideways like that?
So basically their dorsal fin, which is the fin that's on the top of them, has moved like closer and closer to their face. And because they're now laying on their side, what they can do is they can take both their fins now and undulate them like a millipede. So like the way you see like a wave past a millipede legs is how flatfish can walk.
I've seen this. It's beautiful. It's kind of like hypnotic looking.
Right. But it's even cooler than that. So Claire Fox, a researcher named Claire Fox, looked at this in slow motion, and she found that flatfish fin, like the fin rays come together and form like a transient foot to help kind of propel them over the over substrate.
Really?
Yes.
Huh.
Isn't that crazy?
When you say like a foot, is it kind of like a snail's foot almost?
No, more like a millipede, like millipede feet. They come together kind of like piano keys, and they'll touch down on the substrate, and then that foot will disappear. And then another set of kind of contractions will pass. Another set of fins will kind of join together temporarily in time, contact the sand, and move that way.
That's really interesting. Yet another, like, we got the same answer, didn't quite take the same path to get there, but we're doing something similar, I guess.
Exactly.
Are they very fast? Can they move very well that way? They
can, yeah. So that's only one form of locomotion that they have. That's like their slow, kind of like creeping locomotion. But they can move. They can move fast too if they need to. They can like just beat their tail like a regular fish and get out of there.
Have you had a lot of experiences out in the field, like trying to catch flatfishes? And if so, are they tricky to catch?
So if you're in the right place, they're not tricky to catch, but they can be tricky to find. So sometimes like I've gone seining off the coast of Washington and like the San Juan Islands, and not seining, trawling, and they come up like they're just there in like their hundreds.
Wow.
Because we're trawling on the bottom. But in coral reef habitats, they can be tricky because there's so many other fish that are like distracting, and these fish are hiding. Like these flatfish are hiding. But once you find a flatfish, like if you're spearfishing or something, once you find the flatfish, the hunt is basically over.
Sure, yeah.
They present a very wide target.
Oh, yeah.
Yeah, it's kind of, as soon as you find it, it's kind of over.
Just embrace death.
Yeah.
Accept it.
Yeah, I found one. We were out in the field in French Polynesia this summer, and I saw my first like flatfish on the reef, and I just like shook my head. I was like, I'm sorry, man. Like this is
game over, friend.
Yeah, this is over. And the flatfish, he looked at me, he knew. He's like,
He's like, I know what's about to happen. You know what's about to happen.
Yeah. And the thing is, I hadn't been looking for it. I was looking at another fish, and this flatfish, I saw it move out of the corner of my eye, and like I already knew what it was. And I knew it was gonna be there, so I like did what I was doing, and then just spun back around. So I knew it was gonna be there. It's like it's too late.
Has a flatfish ever like done something that really surprised you? Like did something that you were like, wow, I didn't think you would do that?
The answer is yes. They do many surprising things. Oh yeah. So again, I'm a morphologist, right?
Mm-hmm.
So the first thing that kind of caught my eye when I first started this project is I was trying to get an understanding of kind of the anatomy of a flatfish. And one thing that they did, many of them did evolutionarily, is grow a horn out of the front of their face. Now you can't see this horn, externally, but you can see it kind of internally if you're looking at the skull. And it's basically allowed for the dorsal fin to move even over their forehead.
Whoa.
Yeah.
Huh. It's like a unicorn horn?
Yeah, it looks like a unicorn horn. So like the hog chokers and stuff, like they have a skull that looks like that.
They ran out of space and had to make more.
And just added more space.
That's brilliant.
Yeah, and then there are other flatfish that basically have evolved spines, like big, sharp, kind of serrated edges running down like one edge of their skull. And this was like a thing we just found kind of by accident while we were scanning. And I think it's because they use their head as a weapon against like other flatfish or something.
Oh, wow.
That's pretty cool, yeah.
One thing that I've heard, and I can't remember if it was stingrays or flatfish, but I've heard that hammerhead sharks will kind of like flip a fish over. These flat boys, like, I don't remember if it was stingrays or flatfish, but that a hammerhead would kind of like use its like hammer part as like a wedge to kind of like get under there and whoop, like flip the dude over. Have you ever heard of this happening with flatfish?
Yeah, I don't think I've ever heard of it happening with flatfish, but it wouldn't surprise me. Like hammerheads, they use that gigantic cephalofoil, which is packed with electroreceptors, to find things that are buried in the sand.
It's like their head is like a little pancake flipper.
Exactly.
I realize that I've never in my life thought about this until now. I feel like I've known like what a flounder was for a long time, but I've never thought about, do they take care of their babies at all?
I don't think they do. I think they might just be kind of pelagic spawners where they get up in the water column and throw their gametes around.
Best of luck. Hope this works out for you.
Yep.
They sound really like fascinating, and I don't know how I would feel if I ever like came across one if I was like out swimming at the beach or something like that. I have a little bit of a phobia of fish. So if I were to like be out at the beach and I came across a flounder, is there anything I would need to like worry about? Like, can they like bite or sting or do anything like that to like a human?
I would just make sure that you're in like a safe place so that you don't like pass out from excitement, right? Like
have your buddy to catch you when you swoon.
Yeah, have a buddy. No, unless you're catching something like a halibut, which can like thrash around and actually knock you unconscious, then I mean, just enjoy it. Like if you are lucky enough to see a flatfish in the wild, like that's an honor because they're masters of camouflage. They're very good at hiding.
It's a good omen.
Yep. Yeah, it's a great thing. If you can see a flatfish, it's a great thing.
That's a good transition into the last category we rate our animals on, which is aesthetics.
Oh.
Purely how nice this animal is to look at. And I know there's many of them, but if you want to think about the prettiest one or the least pretty one, what do you give flatfish out of 10 for aesthetics?
Look, man, I'm a level with you here. I'm a level with you here. Flatfish do some really cool things with color, and they can get like pretty colorful and like zebra stripes and like peacock spots and stuff. But listen, man, flatfish are getting a 1. That face is horrifying. It's like, I gotta level with you. There's no way.
I don't think I've ever in my life seen a picture of a flatfish that I was like, oh, how cute.
Yeah, because they're not. Because that's not their thing. Being cute is for the other fishes.
They were like, listen, let's just lean really heavy into this very bizarre flattening thing we have going on. We'll just take all of our points out of charisma and put them into something else.
like they have gone beyond doubling down. They're like tripled down and whatever this is. And they won't stop. I want them to.
Is there a way to like see them from head on, from what would be like the front of their face, and like see both of their eyes on the same side? Which I feel like that would be hilarious to see.
Oh yeah, there's tons of photos like that on the internet. That's a classic perspective to look at a flatfish in, because it's like pretty horrifying.
Oh, there was a flounder on SpongeBob. What was his name?
Flats.
Yeah,
that's it. That's what they look like.
And he looks at you like directly into the shot at one point, and you can see that he looks like that. Like, I think it's like when they introduce him as a character, right? When he looks at the screen and he looks all skinny and thin, and then he turns and he takes up the entire frame.
That's Flats.
I know that like the writer and the creator of SpongeBob was like a marine biologist or like had a background in marine biology.
And you can tell. So SpongeBob, first of all, I teach using SpongeBob all the time because Bikini Bottom is this beautiful assemblage of marine invertebrates. And it's like not always obvious. Like plankton is clearly a copepod.
Mm-hmm.
It's like,
yeah. We mentioned plankton when I had Jimmy Burnett on to talk about copepods.
Yeah, not an accident. Not an accident.
For sure, yeah. I was just talking about how we did freshwater sponges, not marine sponges, but still sponges. Got sponges, copepods, sea stars. Now we've got flatfish. So we're like slowly building up the entire cast of SpongeBob SquarePants.
Yeah, filling out Bikini Bottom. That would be awesome.
Yeah, exactly. Since we're still like within the topic, I suppose, of aesthetics, have you ever seen a flounder that you just thought like, wow, that's a cool looking dude? Like, even if they're not cute in the face department, that's maybe like, we can maybe ignore the bizarre face. Like, have you ever seen one that you thought, wow, it has like really gorgeous markings or something really, really interesting to look at about it?
Yeah, so there's like the zebra flatfish or zebra flounder, and these things are beautiful. They're zebra striped all the way down the body, even including the head, and it's like the black stripes are like jet black. So the contrast is really kind of crazy, and they almost don't even look like a fish, right? They look like they could be a flatworm or something, and they're gorgeous.
I just looked it up while you were saying that, and it looks almost like an arrowhead almost.
Yeah, isn't it cool?
Wow, that is a cool guy. They don't look that ugly.
Until you get close to their face.
Yeah, it's a little unsettling if you don't know that their body is flat, not because they're like dorsally flattened, but they're like just turned their whole body on their side. If you don't know that and you think that the side that's facing up is just their back, they look kind of like just like a stingray or something weird.
Yeah.
But then you see like that big old fin sticking right up off the side and you're like, oh no, something has gone terribly awry.
There's also the peacock flounder, which is also gorgeous.
Sorry, you're going to hear my ticky-tack. Oh, it's beautiful. It has these little blue rings on it.
Yeah.
You know what it looks like? It looks like the blue-ringed octopus.
Yeah. So fishes and invertebrates actually do blue pigment with their colors. So like birds, which suck, they mostly do like structural coloration. Whenever you see like the color blue, it's structural coloration. But inverts and fishes do blue pigment.
Oh, score 1 in the fish and invertebrate column.
Oh, yeah.
It's funny because I was looking at pictures of the flounders you were mentioning, and I had to set a Google filter to filter out images from The Little Mermaid. Because that's a ruse. Like that, they have a fish named Flounder that is clearly not a flounder.
Yeah.
Why? Why do they do this?
I think because like a real flounder would be like just too jarring to look at, frankly. And Disney wasn't brave.
They said this is not kid friendly. Yeah. They're going to have nightmares.
Cowards.
They should have gone for it. Look, see, SpongeBob wasn't afraid to go there, and they were massively successful. So
cowards.
Well, before we wrap up for today, I would like for you to take just a minute to let us know if you're working on anything really cool and exciting right now that you want people to know about, where people can keep up with your work, anything that you want to like leave the listener with.
Yeah, so I'm working on like tons of things right now. So I'm working on basically studying the evolution of herbivory, so eating of the consumption of plants in coral reef fish, and I'm looking at the like morphological adaptations that go along with eating plants. Basically, it's hard to eat plants because plants don't want to be eaten, and they've evolved a lot of ways to stop animals from eating them, and animals have in turn evolved ways to get past it. And this is really funny, like
arms race.
Yeah, and like I think animals have been kind of going to war with these like sessile organisms for millions of years. So that's one of the things I'm really, really excited about because I want to look at like rates of evolution when animals kind of transition to eating plants and whether or not they're fast or not.
Oh, that's really cool. Do you see that a lot in fish? Like, do you see a lot of fish that eat plants?
Yes. Yeah, totally. So the coral reef ecosystem is dominated by herbivores.
Really?
Yeah, the biomass of those fishes is mostly herbivorous fishes. And they have some like really crazy specializations, and they feed on all different types of algae and cyanobacteria and plants. And it's really striking. One
fish that comes to mind is like parrotfish.
Yep.
That's the one that pops into my head first. And I think also bonnethead sharks, right?
Yeah, they'll eat plants too. So parrotfish are weird Because like we used to think we knew what they ate, and then we found out that they eat something kind of very not obvious. So they don't really target the algae that's like growing on the surface of the coral. They're targeting like little cyanobacteria that live inside the coral skeleton.
Whoa.
Yeah. So I actually just collected some like stable isotope analyses, which basically tell you kind of where the animal is feeding on the trophic level. And I collected algae and I collected parrotfish. And parrotfish are feeding at a lower trophic level than like macroalgae in their same habitat, which is insane.
Wow.
Yeah.
That goes a little deeper than you might have expected. If you just like looked at them, nibbling away at the coral, you'd think, oh yeah, it's eating algae, but it goes deeper than that. Wow.
Yeah. What you ingest and what you digest can often be very, very different.
That makes sense, right? Because it's not necessarily the things that are going into your mouth aren't necessarily what's making it through the whole process.
Right. Or basically what's being pulled out in your kind of gut and assimilated into your body. Kind of like eating corn, right? Like you can eat corn, but corn's not going anywhere.
Your body doesn't want anything to do with it. So
nope.
That sounds really exciting to work on. What a cool project.
Yeah, I'm having a blast.
Where can people follow along with your work and what you're up to?
They can follow me on Twitter. Just type in my name, Kory Evans, and it'll come up.
Your Twitter name is Sternarchella?
At Sternarchella. It was that was like the first genus of fishes I started working on as a grad student.
What a nice name. I think it's a beautiful name.
I think it's beautiful too. That's why I picked that group. I was like, I just love saying this name.
Oh, it's poetry. Fish poetry. All right. Well, I think that's all we had for today. I just want to thank you for your knowledge and your time today. This has been delightful. I've learned so much about flatfish that honestly, I had never given a second thought to in my life. So
thank you for having me.
We will talk to you later.
Sounds great. All right.
Thanks. Bye.
See ya.
All right, y'all. Thank you so much for listening. I hope you have developed a love and appreciation for our flatfish friends. If you liked what you heard today, it would really mean a lot to us if you could please leave us a 5-star review on your podcatcher. You can also connect with us on social media. We are on Twitter, Facebook, Instagram, TikTok. We even have a Discord server, so please get in touch. We would like to say thank you to Maximum Fun for having us on their network alongside their other wonderful shows like the ones that you heard promos for here today. You can check them out and learn more about the network at MaximumFun.org. I promised a sneak peek at next week's episode, so here it is. Next week on Just the Zoo of Us, we are getting hyped about the big Animal Crossing update. I will be fishing for a particularly heavy ocean friend, and Christian will be paying back his loan to the Nook family. Finally, we would like to thank Louis Zong for our spectacular theme music, which you're about to hear right now. And that is all for today. See you next week. Thank you. Bye.
MaximumFun.org.
Comedy and culture.
Artist owned.
Audience supported.